carry around though.
Or a car phone. I would say get out for BlackBerry, but then they just shut down the BlackBerry servers.
It's okay, they can't send out walkie-talkies. Actually, they could get on your frequency and just like blast music.
Blast Russian music on every single frequency.
All right, guys, let's go with it. That's funny. A presentation, we already talked about it, correct? Are we all good and set there? Just give it to me, email me when you want to do it, and then if it's a PowerPoint slide, bring it on a thumb drive, I'll plug it in here. If it's a Google slide, just send it to me, and then we go from there. So next topic is the rubric, which here it is. There are, I think, I added citing of sources into it. I think that's the new thing there, and I took out something. I forgot what it was, but it was, so anyways, you have your rubric with you. We're good? And so just whatever you use, just cite it here.
Can I just like provide a link?
Yeah, so at the end, links would be fine, web link would be fine, book title, that's fine. If you want to cite it just using MLA or APA, whatever, right, that's fine too. Just as long as you cite it, I guess that's the important part here. Okay, we're good there. Next is study guide for the final. There it goes. That's the next one here. So study guide for the.
Are we gonna go over that at some point before the final?
Like to have a review day?
Questions about it? Like, can I?
Yeah, we have a review day built in into it here. So, okay, so we have 1.4. It goes all the way back to chapter 1.
About that.
Yeah.
I didn't forget how to do it. It's the we did that. It's
And so that one was just finding the remaining trig functions. I've tried to. Yeah, at first what I did is I did all the sections, picked out stuff in all sections, and it turned out only like 74 problems. So then I start chopping until like this is like the bare essential stuff. So chapter 1 was all about just defining trig functions, right? And doing a little bit of algebra with them, so simplify.
What that 4.7 stuff means.
And then chapter 3 was conversions and finding with rate and playing with radian measurement here. That was that.
Oh no, I hate radian.
And then we'll do chapter 4 in a bit here. So I decided to break up. So chapter 1 was kind of this one because it didn't need a calculator here. Chapter 2 did need a calculator, so I put it into the calculator section. So I had it like that. And then we have chapter. There it is. So I think it's right at 20 questions, I believe. So that's about how long we have in a single class period. There's some honor questions after that. Some of them you've seen before, but it's application questions for the most part. Given a figure a little more complicated from chapter 2. And then we have the verbal finals. So here's your verbal finals. So these are homework questions you have done already. You just need to explain it to me here. So from chapter 1.5, we got a few. From chapter 2, 3, and 4, which we're going to cover and find those out.
Aside from the very last one, by the way, they're pretty straightforward, conceptual.
Yeah, I try to make them. There's one, 3.2, I think, needs a calculator. So if you come up, you can have a calculator with you as you do it, but then you have to know exactly what you're going to punch in, not like, hey, let me try this. We're good.
Do we do all of those?
Oh, that's right. Yeah, Max, you've never seen this before. So you have to study all of them. You're going to present one of them only, but you just don't know which one.
Option 2 again, right?
I'm debating. Should we get an option of 2 or not here?
Yes.
Oh yeah,
it's
unanimous.
I can't figure out.
Okay. So you have an option of 2 different kinds. I'll have a random number generator, literally. I click a button, and these will be numbered. And so then you either option 1 or 4. And then you're like, I want to pick 2. I want to pick 4. And then you just do that.
1 or 4.
Everything has to be memorized. So there's nothing that you can bring to it.
Well, I guess you could do it on the spot if you're just really confident that you know the material. That seems like a really dumb idea.
Just a calculator for like one of them. One of them needs a calculator. That's about it. Rest should be
Do you know
all
which one?
sine means this, sine means that, and it's. I think it's. Let's see. Thank you so much. Let me actually write that in as well.
We can probably figure it out when we go through our class.
I think it's 3.2. I think it's that one because you have to solve the remaining parts. Yeah, this number. There it is. That one gets you a calculator if you get that one. Because you need to figure out what is the sine of 25 degrees.
That's the problem.
No, that's part of the
Oh,
problem.
then you just put in
Yeah.
sine 25 and let them go on that one.
I like that one a lot. Okay, we good there? So there's that. Since I can't get to the internet right now, so I can't even give you the schedule. But I think our final is
I know, did they?
24? Okay.
Wait, so it's the Monday before we get out?
Yeah.
Well, no, that's the written.
But the written final is the 24th, but we have the option of doing the oral final next Wednesday, Friday, or the last Wednesday, right?
Yeah.
And we do the
Options for that.
time in between them.
Wait,
Mhm.
verbal finals next Wednesday, like when we get back after this long weekend?
That Friday, if you choose to do it that way, or that Monday afterwards, or the Monday after that. So you can choose to do either one. I will be okay with any one of those here.
Basically, I should start studying.
Okay. Let's see. Last time we finished up with 4-4. So any questions off of 4-4? And
Yes.
and we think this is the last one we did right here, right? This is the connection between the two. I do have both pins with me. Okay. Okay. Let me get rid of my. All right, and if you want to take just a little extra time to turn in your homework for it, that's fine too, right? Because homework would be due this Friday. But if you just need extra little time with the graphs and stuff, I'm okay with giving you guys a little.
The graphs take forever.
Yeah.
Yeah. It's the, okay, 4-4 homework, anyone, and then we'll jump to 4-5.
41 I didn't get, and then 22 I'm just confused.
Okay, no problem. 22? Because that's an even problem.
Yeah.
So you tried it, yeah? Was it on the homework?
Yeah, I think so.
Oh, wow.
Yeah, it was.
Interesting. Why did I do that?
Maybe like 23.
I think I meant 23. Yeah, I just punched in the wrong one here. So sorry, guys. 22 should have been 23. It's the 23. No point in giving you guys even problems when you don't have the answers to them. So let's do 23 then together. And then since I accidentally put that one in, boom, we're going to do a cotangent graph. That's cool like that. So you guys guide me through the process here. What do you guys say?
Is this from 4.3?
4.4.
You have period.
Period. Okay, so that's cool. So period is going to be pi divided by b.
Which is pi over 2. Then it should just be 2, right? And you multiply both sides by 2 and then cross out pi.
Interesting. Now, notice whenever that is a multiplier to t, right? We get ourselves a real number. Or one without a pi next to it, right? So that's cool, okay? Anything else that we do for cotangent and tangent? Vertical stretch, ST for stretch. Do we have a vertical stretch? 1/2, perfect. Yeah.
No phase shift.
Perfect, yeah, no phase shift, no reflection, and no vertical shift. Perfect, okay, so let's see. Going back to just knowing the cotangent graph a little bit here. We have dashes, vertical asymptotes at 0 and at pi, and then cotangent comes hits the 0 at pi over 2. Also, it has this little dot here and this little dot here. So I have 1/4, comma 1 originally. And this one's going to be 3/4, 3 pi over 4, comma -1. Those are our three.
That's cotangent. Tangent, it goes from pi over 2 to negative pi over 2, right?
Tangent goes from negative pi over 2 to positive pi over 2 as far as
So it's just
vertical stuff.
Yeah, okay.
Cool, so I think we can build this out here. No vertical shifts, no horizontal shifts. I'm going from 0 now just to 2. Here's my dashed line right there. That's 2, that's 1. But then I have a dashed line at x equals 0, and it's going to look the same. That's why we can do it by scale differences, or we can do it by moving the graph over here. So I got a dot right here at 1, so I got myself a 1, 0. Vertical stretch, technically a compression, right? Compression. And so I can do this right here, graph this guy coming down and then coming down some more. And then this little piece is going to give me, it looks like what you guys say, a 1/2, comma.
We have to write the points too.
On more complicated graphs, no. Some of them, yeah. I mean, I'll go one or the other, as long as you have, as long as it looks like I know what you're doing.
If you label the sides more, I guess.
How about 1 1/2 and -1/2? Is that right?
Can I say 3/2? Is that okay? Do you
3/2 is perfect. Okay.
I tutor my little brother. He's doing improper fractions, and he gets them all wrong because he doesn't put them into mixed numbers. So I had to ask. Still a thing.
Yeah, that's right. Elementary school, you got to put them in. Okay, we good there with that one? Another cotangent for 41. Dylan, we good there?
Yeah, why is the coordinate 1/2 and 1/2? Is that only just the vertical stretch?
Yeah, because let's see, we're going from 0 to 2. So we already built the 0 here, so then half of the 1 would be a half. And then we also have the vertical, technical vertical compression.
So I think it's just like on another cosine graph very well, but like for this stretch, is where the dot is, or where the dots are, would that normally be 1 and -1?
Yeah, it's this guy here, and it's a 1 normally, but because the compression or stretch, it's gonna change
Okay,
it
so
up.
it's just the same exact graph, just a different scale then. Okay, that makes sense.
Absolutely. So notice, yeah, it's the same exact graph. It's just a change in scale. That's all it is. Cool. 41. Ding ding. All right, help me out. What do we got?
Just a phase shift.
Only thing here is a phase shift. We got ourselves what? Pi over 4 to the right. There it is.
It's the same thing, just moved over to the. It's just for the vertical and folks that are at 1/4 and 1 1/4, basically.
Well,
So then let's see, instead of pi being over here, I'm going to shift it over. This would be pi over 2. This would be pi over 4. 3 pi over 4. 4 pi over 4. 5. I gotta build out the scale for yourself just to make sure you get it.
I don't know why I need help with this. Maybe I'm looking at the other one. Really straightforward.
Oh, that's okay. So glad we able to go over it here. So I got myself vertical isotopes at pi over 4 and 5 pi over 4. We good? Everything got scooted over, so that means my 0 is at 3 pi over 4. I guess if you draw your scales well, then I can read it easily here. So I know what problem you're going to get to. So pi over 2 comma 1 is what we have here. And pi negative 1, technically. That should have been further out. I wouldn't more like.
Well, it's so satisfying when you draw the line where it has the right shape.
Mm-hmm. Boom. There it is. That's cool. Okay. Are we good there? Do I have a new one? Okay. Should have a new one. All right, now the time is to go backwards. So I'm going to give you guys a graph, and you guys give me the equation that corresponds to it.
Oh, this sounds very hard.
It doesn't.
No, it does. It's not hard.
Because in this case, we don't have to draw the graph.
Well, it might not sound hard to you, but I'm saying it sounds hard to you. Drawing the graph isn't hard. It just takes a while.
I'm just going to give some.
You're gonna take that one and look at graph.
Yeah, it's actually going to take me, probably going to take me longer to graph the graph nicely before you guys actually can get to it here. So I didn't get any. I mean, I tried. Uh-huh.
And while you were in first before, did he tell you that it was really long, as I said?
It's not written as due though,
Yeah.
at the right time.
Because that's kind of
It's written to do the same day as the other essays.
why?
It's
Because
not ours.
we're doing the honors T, not this Thursday, but next
Next week,
yeah,
yeah.
next Thursday, and then to do the Wednesday
After that.
that we get out of school.
So the 26th. Yeah, our SE3 is due that day, but it has on the syllabus and the director so there's nothing else.
We should, this is going to be our fourth honors essay. There's no only two.
These are four.
I think so.
Wait,
No,
So
what?
it's not good.
There's only
It's
two.
not full.
It's because we did
This
this
is why
podcast.
they used to
We
do
didn't
it.
have
The
to
podcast
have
was,
pages.
oh, that was annoying. First Play-Doh, oh gosh, what else did we do? All day.
All the,
The same stuff in the honors essay.
Is that it?
He was playing the part of the podcast, like the lines podcast for our class, and right as he got to the part where they were going to explain the guys, yeah, but what about the sky? He's like, all right, we'll listen to the rest on Friday, and then we never listened to any more of it. So the main section of it
Did you
was actually.
Okay,
all
this
the
actually won't be
podcast
too
thing
bad, I guess.
and-
Mm-hmm.
So it's,
See, that's close enough.
yeah, so it's just gonna be the.
oh, wait, this is just 1.5.
Is it supposed to be this simple?
Well, this
Of
one
course,
is.
this is
Our first
example one.
one.
Yeah.
Okay, because I'm like, oh, how complicated is that?
So,
I have two thirds and 7 pi over 2 lines. Yeah.
good. I got myself y equals, and tell me the answer.
2.
Perfect. Yeah, that's a nice cosine curve already. It has a period of 2 pi. Everything's nice there, right? No change in period. The only thing is, it just goes up to 2, goes down to negative 2. So therefore, that is good good there as far as 6.
Wait, sorry, if there's reflection, does it come in front of the vertical stretch if it's in the front, or vertical shift, or does it come in front of the
If
amplitude?
it's a relaxed reflection, it would be negative 2 cosine x.
So it is in front of the amplitude, not the vertical shift.
Mm-hmm. Mm-hmm.
Yeah, the plus or minus for the vertical shift is up or down.
Oh, yeah.
Mm-hmm. Oh, can I go off on a tangent just for a second here? We were doing calculus class. I thought that was kind of cool. Let me bring it up real quickly here. 3.4. Yeah, this one. So in astronomy, we have something called these kind of stars. funny stars. What they do is they get brighter and less bright through a series of, I think we could probably do this here, let's see. It reaches a maximum brightness every 5.4 days.
Why do they get brighter?
I have no clue.
Can't you buy stars? Buy a star and name it after yourself?
Mm-hmm. I wonder how many people have the same star label.
Yeah.
So we have stars that go up, increase in brightness, and go down in brightness, but it occurs every 5.4 days. The average brightness on a scale, average brightness is 4. And if we want to see the scale change, right, this is how many days. This is how many days it takes, right? This is the average brightness according to a meter system. All good? And then the max brightness it gets, I'll just put max B, that's the max brightness it gets. We good?
What unit do you use to measure lumens?
And I mean, it won't be even lumens, maybe hundreds of lumens, or I mean, but it's a star, right? So like million lumens, I guess.
Yeah.
And so what we have is we have the brightness of it at 0 days. When we start just counting it, we're going to count at 4. We good? So 1, 2, 3, 4, and we're going to scale it so that it's going to start getting brighter and then starts going down. So my question to you guys is, we could actually do this at the end, huh? If I do that, there's that. The top of it is going to be 4.35. The bottom of it, and that scales off. Sorry. 3.65. I think I'll go with that. I have to say I have a break. I gotta say I have a break right here, so to be appropriate there. Okay, at the end, we're going to try to figure out the formula for that guy. We good? We're just going to keep it aside here just for now. We'll come back to it.
Question, why is there trig in the calculus test?
We were taking something called the derivative, which we're trying to figure out the slope of the brightness. How fast is the brightness changing at what time? What time does the brightness change the fastest? When do you have the tops and the bottoms?
That's
for
next year for us, right?
Mm-hmm. I mean, if you take that.
So, well, yeah, that's kind of cool. We'll get to that. We'll get to that one at the end here. So let's go example 2. So, yeah.
I have a really quick question.
Yeah.
When you say going on a side tangent, is that related at all to trigonometry? Is the origin of that same?
No, I think they come from 2 different spots.
So
Yeah.
So it's just a
Tangents
homonym?
are different from sine and cosine, so it's like a side tangent.
Side tangent.
Because I was wondering about that, because obviously I've heard that saying a bunch, but in studying of a trigonometry classroom, I was like, oh, I wonder if it's actually related.
Yeah, I think the origin, yeah, one of them's more like an English origin, the other one's a strict math definition. That's cool. I
The
wouldn't.
English just needed another word and fixed tangents. Oh.
Could be. Okay, let's jump. So what we really are working with this right here, if we kind of think of the formula here, y is equal to a cosine. I like brackets personally. So if we can fill in all these pieces, we have ourselves everything we need. We good? So you can substitute sine into that as well. And notice most of these guys, as we do these here, they're going to be sine and cosine because they're going to be oscillating functions for us. Tangents done. So all yours for this one. This one probably should be still an easy one as well. So -3. Oh, then of course I'm going to change it up on you guys here.
Just draw the sine and cosine. It's literally just doing sine and cosine. That's a lot.
They're the ones that do this.
Yeah, but you just draw the sine and cosine curve and you just take the top line and nothing else.
Yes, so
I'm gonna go with it. Try to graph it twice here. Still didn't graph the way I wanted to graph it. All yours there. That's not that phone, is it? That little, is it that phone right there? No.
Nuclear sound alarm, but I got dimmed.
Yeah, because the Russians couldn't destroy it completely, so they just dimmed it up to low decibel levels.
Might not be the Russians either.
The-
Lebanese.
When you plug the B for B into the thing for the fish period, it's 2 pi over B, right? Because it's
For sine and cosine, it's 2 pi.
Okay, yeah.
And then for tangent cosine, it's just pi, right?
So let's do it. Let's see. Let's do it together here. So first things first, I do see it as a cosine curve. That's nice. It's reflected, right? And the amplitude is 3. So this guy comes out as -3 cosine. And then we got to look at the change in our period. So we understand this guy to be this here. Period is equal to 2 pi over b, except we're going to work backwards now. So this guy's pi. This guy's 2 pi over b, and we need to solve for b.
2 multiplied by
Multiply.
It's 2. I know. How do you get there?
Multiply by b, and divide by.
Divide by pi.
Divide by pi. Right there. Those guys cancel, and we got ourselves b is 2. That's perfect. Okay, cosine 2 x. Is that it? Do we need anything else? Yeah, that's it. So this guy goes away.
-3 cosine 2x.
And simplifying a little further.
not complicated enough.
This is 4.5, right?
This is 4.5.
Okay. I didn't realize before we finished 4.4.
Oh, gotcha. Okay. Okay. Boom. I'm gonna do this right here.
Is any of this going to be on the test? Part of that, obviously?
I think it's only 4.3, 4.7 on the test, right?
Ooh, let me check again. Because it should
Hey,
be.
this stuff seems pretty.
This should be on the test. If anything, I should. Yeah. Let me check.
Should
This should
replace
be.
all the hard stuff with 4.5.
I know I put it into somewhere. Either it's a verbal final or written final. I had a mesh. I had to separate them out so at least I can test everything.
I guess that actually might be wrong because we're still.
Yes.
Mhm.
Oh, give me one. Well, we have to draw the graph first. No.
You guys ready for this one here? Same problem. I want you guys to give me the sine equation to this.
Oh, bro.
Oh,
We're at the same shit.
oh, bummer.
Hold on.
So you guys talk to me. So I need.
It's just 1 or plus.
Either way, actually, I'm pretty sure it's the same thing.
Isn't it just plus pi over 2 after the log?
Well, it's not pi over 2, it's pi over 4 because the period is pi.
Well, there's still
But I mean half of this.
All you have to
period.
do is shift it over pi over 4 that way, and you have the sine curve.
But why would it be pi over 4? Just if you want to chop off half the curve.
It's just a
It's not
reflection.
half the curve though, it's a quarter of the curve.
Isn't this just a...
Oh, I see what you're saying.
Yeah, it's a reflection with a shift of the plot. That's just pi over 2 is
Guys, talk to me here.
So it's still -3 of sine. I think.
Well, no, it's not -3, it's just 3.
Ooh, yeah. Look at this. Notice if this began here, right? If it began here, it would have been just a sine curve, huh? Right, we don't need the flip anymore. Okay, so let's see. Let's go to this one here. So this is just a 3 now. So do we know what b is?
So isn't it just 2?
Well, it's still 2,
It's still 2,
but it's x
That's plus pi
4.
So it's just 3 sine.
Yeah, and technically, it could be negative 3 sine of 2x minus pi over 4 also.
As long as you put a negative 2 in front, inside, yeah.
Negative 2? I thought it was negative 3.
Oh, you put a minus here, you mean?
Yeah, negative 3, because if instead of shifting the one pi over 4 to the left, you
I was
shift
doing
it pi over
reflection
4.
of the other.
If you shift it pi over 4 to the right, then you have a reflection of sine. So
No,
you
it
have
has to be
negative.
3 pi over 4.
Mm,
Sorry, to the left, to the left.
or you just do 1 to the right.
Yeah, but no, but I'm saying, if you were just saying it could be negative 3 sine, but
Negative
then you'd have to do 3 pi to the left,
Mhm.
3 pi over 4 to the left.
or x minus pi over 4.
I think in back of the book they're going to give the answers like this, I believe, right? They're going to multiply in the 2. Okay? But let's do what Isabel was saying. If we went backwards this way right here, right? If we started here,
It's a reflection of sine.
the reflection of sine, so we've got a negative 3 in our hands. Sine of, still the period's 2, or the b value is 2, x plus pi over 4 this time, right? Oh, minus, sorry. Come on. Give me the minus. There's my minus.
Yeah.
Out of it here.
That's just more complicated though.
Hmm. 1 second, let me sit there just for a little bit here. Minus. Yeah, 1 second here. Go ahead, go ahead.
The reason it's, oh, I see what you guys do. You factored the 2 back in.
Sorry guys, real quick here. I made a little mistake here. This should be a minus sign, is that right? This should be a minus sign right here.
Hold on.
True, true?
No, because it's positive if you're going to the left.
Yeah, so negative.
Oh, but yeah, we're going to the right.
Yeah.
Positive going to the right, and it's
Then we're
moving
going
up to the right. Yeah, okay.
Now we were going left, yeah.
Is that correct there?
Yeah. I'm just confused.
Yeah.
Why is it pi over 4?
Pi 4 originally right here?
No, wouldn't it
Oh.
be minus pi over 2?
So this would be pi over 2 right here. It would be the halfway point between here and here. So that means this would have to be pi over 4.
Oh.
So
Shouldn't those be switched because the phase shift is the opposite? So it should be minus pi
But
over
that's
2.
the one.
We're just going 1 and 2.
yeah, that's what I'm thinking too. Like I'm
Yeah, and then
stuck
for
on
this
that
one,
just
it
a little
should be
here.
plus pi over 4.
No.
We have a reflection.
Negative 3 sine of the 2 whatever stuff is if you're shifting
That's phase shifting to the right,
to the right.
which means it wouldn't have the reflection. That's the first one we did. So it should be 2x minus pi over 2.
What's up there is right.
Yeah.
I just erased it. So yeah.
No.
Exactly. Because this right now, if you take out the 2, you get the period, and then the period is 2 pi over 2, and you have period of pi. And then left is you have minus pi over 4, which means that you're doing a phase shift of pi over 4 to the right.
We weren't going to the right with that one though. We were
I
going to the
know,
left.
and we had it wrong. No, for that one. See how we have the dotted line? For the first one that we did? The first one that we did was going to the right. So that's right, the bottom one. And then the other one's also right if you make it a plus pi over 4.
We'll hold on. No.
So yes.
No.
Okay.
I think.
You guys talk to me. One of them's right, one of them's wrong here.
Back me up here.
Dylan, what do you
It's
say?
possible. If you guys were going to the right on that one, I went to the left. I shifted it pi over 4 left.
I'm not gonna lie, I did what Isabel did.
And then it's 3 because amplitude sine of 2
So which side of the whiteboard are you talking about?
Oh.
Yeah, so you have to
The first
have...
thing you wrote, because it needs to be, if I thought we were shifting pi over 4 to the left, which means it has to be x plus pi over 4.
Good. See, before he drew the other half, we were shifting it to the
Yeah, so let me do this here. Before we put in this right here, we're at a graph that looks like this. Is that right?
That's what I thought we were writing with the 3 sine of 2x
So here's 3
Plus
sine of 2x.
pi over 4.
It has to be minus.
So 3 sine of 2x is the dotted line, right? That's what we have now.
That's,
It's going to be a flip of the other one.
It would move, see the full dotted line sine curve? If you have plus pi over 2, it would move it over to the left.
That's good. I just want to make sure that this is important to spend time on, just to make sure we clear it up, because
whoa.
the dotted line just shifted over to the right.
This right
pi
here
over
as
4.
a sine curve
sorry.
is minus pi over 2, because move it to the right. If you do this, then that's the reflection, which is the minus 3, and then you have plus because you moved it over to the left. So then it's reflected and moved over to the left, and you're positive.
I agree with Abe. Because the dashed line right now reads as 3 sine of 2x, correct? So what we're going to do from this dashed line to the solid line, we're going to shift to the right pi over 4. So in this case, shifting to the right means that right there. And then simplified version would be this right here. Let's do another one as well. We'll make sure that we do another one.
Then I was originally confused on what we were doing with the other equations in relation to sine. Like from the beginning, I wasn't right on what we were creating.
Are we still getting the right answers though?
Well, no, because I had said that it should be x plus pi over 4 right there. Wait, so I think where I went wrong then is I didn't, like from the start, I didn't realize exactly what we were creating a y equals formula for with sine. So then I had the wrong answer.
Well, the plus pi over 4 is the right answer. You just have to add the reflection.
So this one right here.
Didn't put that in.
Yeah, for this one. So
I
now
was
if you are,
from the beginning about something that I didn't realize I was wrong about.
Gotcha.
Something,
If we
but
were
I don't
to-
know what.
if we were to go backwards, so if we're going to go to the left, we have a curve that's going like this, right? And eventually ending up right here somewhere, right? So if we shift over to the left, that's going to be a plus sign on our hands, and then we're going to have to do a reflection because we're going to have to bump it down now into here. So now notice this little piece right here, -3 sine of 2x plus pi over 2. That one and this one.
Either way, there's a negative, it just switches way.
Let's do this here. Yeah, still, sorry for making this more complicated. I added an extra problem just for the fun of it. It was not originally in the notes now. So let's do this. I'm going to jump to, where is my, oh, not here. That's not it. It's here and here. There we go. Let's solve this problem here. So we're going to tack in a -3 cosine of 2x. Everybody good there?
You just put all 3 in and if they all line up.
So we have ourselves a,
3 sine.
see, I think it's going to go, okay, that's going to be, I don't want that window. Let me get a different zoom window in here. Window, and this is number 7, is trig window. Okay, so there it is. Does that correspond to what we have?
Yeah.
And then let me see what the window says. It's -2 pi. It's going to go 0. 0 to pi. And then pi over 4 is our tick marks. Does that make sense, guys? And then we're going to go -4 to 4 is a nice scale there. So let's see. This graph looks like this. Is that true?
Yeah.
I do, and I think the frame rate is
And that's 12 FPS.
Okay, let's punch in
3 sine.
3 sine of, so I don't have to do the extra parenthesis here. Let me just do 2x minus pi divided by 2, right? It's just a multiplier already built in. Hold your breath.
Yeah, it's the
Same
same.
thing. Then we go over here, we actually go like this, right here, right? Just to make sure that we know. There's my graph. It's the same graph. Okay, so now let's jump over here. Negative 3 sine of 2x plus pi divided by 2. Okay, so now let's take a look at this one here, and holding breath. Phew. Okay, now let's get rid of this guy and make sure we get the same exact curve. Interesting. Okay. Next is if we did want to go the other way here, right? So if we did want to go minus, it just, let's see something here. It is the flip of it. Yeah, so it's pushing it to the other way.
Yeah, I got confused somewhere and then didn't realize that I was confused.
Mm-hmm.
Because this all makes sense now.
It does make sense now?
Yeah, but I don't know where my brain was before.
Okay, no problem. As long as we've
Oh,
making
at least it
sense,
wasn't
that's
just
good.
me.
Let's do one very similar to it, just to make sure we got it here. So example 3. Thanks, guys.
Oh, question. When
Yeah.
if we do this on a test, or if it's in the oral final or whatever, should we do the, I'll say, simplest?
Correct, yes,
Like,
the
for this,
simplest,
we would have done the cosine one, because
Mhm.
it's easier than.
correct,
Instead of this, oh.
And will we have to put it in the 2x minus pi over 2 form, or can we do 2 and then x minus pi over 4?
Either form is fine, yeah, as long as I have the correct.
As long as you're correct and it's not like it's a matter of simplification, then you're fine.
There's that one.
Is that 1 on top of this
So
one?
period is pi over.
Pi over 2. No,
Yeah, period is pi over 2.
if it's,
Cosine.
oh yeah, I think that's sine curve.
So is the top of that
That's
at 3?
3,
Or what?
sorry, there it goes.
Okay.
Okay.
We'll get into shifting it around just a second here, but not yet. Okay, just for practice. Just for practice sake, let's do a cosine and a sine, right? Let's do both. Let's do so we can have that shift over. It's really easy to just use the other one and that's it.
We're doing cosine and sine?
Cosine and sine, yeah. Can we do both? So give you guys about 2 minutes or so. Okay. And Max, are you almost at chapter 4? Is that kind of where you are? Okay. Okay.
So B is 4
Wait,
then, right?
I was like, I don't even know if we there was.
Yeah, 3.5 I think is the.
That's going all the way.
Yeah. Yeah, wait, so how come for those chapters they only want the 0.5?
Just whatever concepts are in the chapter.
I think
Yeah.
B is 4.
By the time we covered radian measurement,
Oh, B is 4, but you said
it
you
needed
cosine
4
and
sections,
sine.
and then the velocity was at
I'm doing
4
cosine.
sections. So
Is it just 4x then?
Yeah.
Like for sine, my brain really thinks it's just easier to do.
Same. But that's not what we're doing, though.
But the whole thing's on it if we move it to the right.
That would be shifting
The
each
whole
other
sine
back.
curve is on the graph.
It's, oh boy, oh boy, oh
So we
boy.
have to move it over by 5 or 4.
No, it's pi over 8.
Yeah,
Oh yeah.
because it's cut in half.
Oh boy.
Okay, let me do the easy one first. The cosine comes off easy one. Just because it looks like a cosine.
So you can do it the other way. So I think you can do it.
Yeah. So the reflection. So it could be
We good there? Are we okay with the -3?
-3 sine 2.
Atali. Good. Yeah, okay. -3. We have a cosine curve here, and then the b value is what we're trying to figure out right here. So it looks like if I take pi, but if I chop it in half right here, that's one form right there. So my period is going to be 2 pi over b, but then this guy's going to be pi over 2. Pi over 2 is equal to 2 pi over b. So we've got two fractions on our hands. I can cross multiply those guys.
This thing is done all except for 4. Except for when I got confused.
Divide by pi. Cross out the pi's, and I got myself b is equal to 4. So if we got that, that's great. And now this one, there is no, everything's 0, right? If you want to include the zeros in there, you can include the 0, 0, 0. And we've got ourselves -3 cosine of 4x. Good there. Now the sine curve. Again, I see the same thing here. I see it shifted over this much. Whew, what the heck is that much?
It's a quarter times 2, so it's pi over 8.
Awesome, So to be down here, this guy would be pi over 4, not drawn to scale at all. This guy would be pi over 8. And so as we do this here, and this is a regular sine curve though, because it goes up.
So this is just 3
sine
of 4x minus pi.
Pi over 8 originally, plus 0, but yeah, eventually when you multiply it in, 4x minus 4 over 8, so pi over 2 is the original scale here. Okay, so I think
over the last one, you can do the reciprocal, not reciprocal, reflection, and have it -3 sine of 4x plus pi.
Yeah, we're not going there yet. You didn't do what?
that's interesting. Sure. Okay. Yeah, my thing is, you know how a sine is an odd function, right? So let me tell you what I'm thinking in my brain. It's negative theta. And a negative theta can be pushed out to give you a positive theta, right?
Oh, that's why the
So when you push this out, that's why it changes.
You just switch them. But then you need a pi over some or other.
So- Well, that's why I was confused on the last one here, because if you do this one, let's do this. Just we have enough time, yeah. So if I go backwards over here, right? I go like this. What's that going to be? -3 sine of 4.
x plus
Okay, so I see that right here, right? So I see -3 sine of 4 pi plus what, pi over 2? So notice the negatives on the outside, negatives on the inside here, right? Notice the sign change right here and right here, right? But notice there's no sign change on the 4. So that's one I was confused on. So what's happening here is the negation on the 4 is actually a swap across the y-axis. That's what's happening. Right, because it's the negation of a negation, so it swaps it with the sine curve change. Sign change. That's weird. That was why crazy stuff went in my head. Okay. Exercise 4. How about this one? A little bit more complicated. Let's go with it here. This is now, I got myself a 10. Goes up to 60. Goes up to 110. That goes 10 and that goes 20.
Okay.
And it goes like this.
Does that hit 110 or does it pass 110?
110, sorry. It's supposed to hit 110. Maximum should be
I
110.
do not actually have like a graph to drawing on, so I'm just checking.
Sure. Let me graph it the way it's supposed to be. So let me actually put in the dots, because that'll be easier to put dots in. That's 110 in the middle, 110 in the end. So it goes like this.
Here's 10. Yeah. So wait.
Oh gosh, this is mean. Oh, wait.
Also, the center is 60, so it's also 60.
Good, good. I like that.
It's not a phase shift though, so that's good.
So you don't have to do sine and cosine. Just do one of them. Just do the easiest one on this one.
Cosine.
Cosine is easier. Okay, so we have ourselves that as the setup.
I'm getting these power of 5.
Yes.
Oh,
Yes.
it's just like weird.
So all yours here. So we have that. Amplitude is reflection. Yes or no?
Negative.
-50. Perfect. Got that. Cosine of what's my b value? No, pi over 5. You already said, yeah, pi over 5. Okay. Its period is 2 pi over b. The period is 10 multiplied by b. Divide out the 10. Simplify, done. So pi over 5.
It's x minus 0. It's plus 6.
Ooh, that's right. That's right. Plus 60. So simplified form. Boom. Okay, are we good there with example 4?
Why is it -50 for the amplitude?
So the amplitude is 50, because if you cut, the difference between 110 and 10 is 100.
Yeah.
And you need to cut that in half. So it's 50.
And it's negative because there's a reflection.
Okay. That's it. I didn't realize you were. Oh, yeah, I guess that makes sense.
Cool. Okay, talk to me. Are we okay with that one now? Okay, jam, exercise 5. Okay, I got this one. This will be fun.
Why can't it be trigonometry? Yes. That'd be so much
I mean, I think trigonometry would be easier than algebra 2, but honestly, I think it is.
so far.
Really?
About halfway through the year, yeah.
Yeah, something about that stuff.
Oh no, hold on. Sorry. Yeah, let's see.
The angle with both direction and that.
Okay, no, okay.
Despicable me.
Wait, what? Oh, hold on. Negative pi over 6 pi over what now? I'm confused.
1, 2, 3,
Let's move over.
that's 4.
Yeah, I don't. Why did it pi over 2?
That could be it.
Oh.
There it is.
I'm honest.
Horrible.
I need the sine curve as well as the cosine curve.
We
on this.
both.
Sine is easier.
Sine is easy.
Yes. Because it's a sine curve shifted up 4.
Oh yeah. No, it's
Shifted up 3. No, hold on.
No, it's shifted up 2. But the amplitude is 2.
No. Sine normally hits 1. If it has nothing changing on it. So it has to be up by 3.
No, but the it's shifted up by 3.
Amplitude. Hold on.
It's shifted up by 3.
Oh.
Hey, what's the amplitude?
Amplitude is 4.
Uh-oh.
Amplitude is 2, but
I
it's
was-
shifted up by 2, which equals 4.
Okay, yeah, amplitude is 2. Okay.
And then the period is. We have to figure out cosine first for the period because.
But hold on, does sine and cosine share the same period?
Yeah. So we just need to. So the period is.
Period stays constant all the time, right?
What is
Between the two. Right, so
I
fine.
guess if we know that it's negative.
Amplitude numbers. 2.
The whole way we go.
It's also 2 of cosine, except cosine is upside down, so.
No, I mean, there's a big
No,
period
what's it
just-
upside down? Ah.
Yeah, isn't the period just 4 pi over 6? That's just the cosine. Right?
4, 5, or 6.
Yeah, I didn't give you this one here, right?
Well, yeah, but
For cosine, we can figure out the period for that and just transfer it over to time.
Mm-hmm, absolutely.
it's just the difference between pi over 2 and negative pi over 6.
Yeah, it's the subtraction between these guys, right?
Wait,
Oh, I know, isn't it? Yeah.
Or the difference. You say difference, but you're going to add them
how
up.
do you
Because
shift?
Well, it's pi over 2. It's pi over 2.
Plus pi over 6.
Yeah, which is just 4 pi over 6.
for the
Which is
period.
2 pi over 3.
Interesting. So notice we're using that. Right, we actually do one more step, right, to figure out the
yeah,
period.
1/6 of
Yeah. So it's 4, 5, or 6. So that's the
No,
period.
it's 2 pi over 3 if you think about it.
Yeah.
Yeah, but that's the period.
Yeah, which is 2 pi over b or
2 pi over 3.
And then there
And then
is
2.
not.
So 2 pi over 3 is what we got for the distance between them, the period. That's not our b value though, right?
I have to be not the b. It is math.
Wait, how is that not the B?
Because that's just our period, right? That's just the length between the two.
To get that, you just have to. It's just 3. Yeah. The B
So
value
then-
is just 3.
Yeah.
Yeah.
Period would be pi
Do you have to
over
reflect
2
those
pi over
lines?
b.
No, I'm sorry.
So this one, 2 pi over 3 is equal to 2 pi
There's
over.
no phase shift
b.
in sine 1, is there?
No.
No, but there is for b,
Can you
for
just do also
cosine.
2 pi over 2 pi over 3?
I got 2 pi over 3 equals 2 pi over b, therefore b equals 3.
Oh, I actually think I have sine 1.
Oh, yeah, okay.
So I think I got the.
Well, it's a shift of pi over 6.
So for the sine curve, are we okay with 2 sine of what, 3x?
Yeah. Plus 2.
Plus 2, gotcha, okay. Are we okay with there for the sine curve?
And the cosine has reflection.
No.
So if you go down here, right, if we're starting here, right? So there's a reflection of that one, so amplitude stays the same.
Then aren't you going to be adding pi over 6?
That's fun.
And 5 or 6,
We're adding
uh-huh.
You have to shift it left to line up with the current graph.
Mm-hmm.
And plus 2.
Ow.
3x plus pi over 2,
Yeah.
plus 2, final answer.
No, it's not.
It's not hard, I said it's both. It's easy to understand, but it's so hard to do both.
So, could we have,
It's a bit long. That's a bit, but.
we could have shifted over to here too, though, if we wanted to, right?
Wait, what for cosine?
For cosine?
Oh,
So you could have shifted.
yeah.
So is
Because
this,
there would have been no inversion that way.
uh-huh.
But that's a weird.
It's like what we were arguing about earlier. You can either reflect it and have plus pi over 6, or you can not reflect it and have minus pi over 6.
Mm-hmm.
I would rather go left. Which is
Mhm.
weird, but I would.
Well, because the whole thing's on the graph if you go left, it just makes more sense.
Yeah. In this case, it definitely makes sense.
Yeah.
Depending, it might not.
All right, example 6, something we looked at initially here. So this will be example 6, and still came back to it.
Oh no.
Now, let me see if my internet works or not.
Amplitude of
Does it work? Come on, come on, come on.
3.5?
Yeah.
Yeah.
The amplitude is 0.35.
Oh my gosh.
The period's 5.4.
Ah, okay, internet's not up. I was just gonna get a,
Oh my gosh.
I wanted to get a picture of these stars.
5.4
Okay, there has to be a pi.
pi times 1 over 5.4 plus y.
I don't want to call. No.
Wait, so b is 2 pi over 5.4?
I'm thinking sine curve, is that right? I'm thinking
Yeah.
sine curve?
Seriously? Is
No,
that
no,
accurate?
it's not 2 pi over 5.4, it's 5.4. You figure out what 2 pi over what equals what.
B, I didn't say the period.
Oh, B isn't.
You can't see that.
No, B isn't 2 pi over. No, no.
Yeah, it actually is.
Period is 5.4, which means 2 pi over
And so
something.
5.4 equals 2 pi over b, multiplied by b.
No, the 5.4 equals 2 pi over b.
What's my A value?
Yeah, because there's different things.
What's your A value?
Yeah, what's my A value? 0.35, okay.
But then you have a
Right, because it goes up, wait, 0.35 goes down, 0.35, perfect,
you have
sine
a
curve.
vertical shift of 4.
Mm-hmm.
Oh, no, not a 4. Yeah, 4, yeah.
So,
So at the end,
The vertical shift
4
of
is at the end. Uh-huh.
Period 5.4.
The B
don't
value,
have
what's the
phase shift, thank goodness.
Oh,
You
yeah.
just have to figure out the period.
What is the period?
Yeah, I think it has the answer. It's kind of weird, but
Go ahead.
I actually think it's right.
Go ahead, Isabel.
Because if you do the algebra from 5.4 equals 2 pi over b,
5.4, whoa. 5.4 equals 2 pi over b. Okay, yeah, go ahead.
then when you multiply by b
Mm-hmm.
and then divide by 5.4,
Mm-hmm.
which is the same thing as multiplying by 1 over 5.4,
Mm-hmm.
which is 2 pi over 5.4.
Mm-hmm.
Technically, you can simplify
This
that
would be 2. Oh, we don't need to.
So my
to pi over 2.7, yeah. I don't know if that makes a lot of sense though. I guess
Over 2.7.
If that's the case, let's look at the last problem. Let's replace b in the equation with the value that's from the graph. You can solve it, and that's your actual b value.
so. Wait, what is this b
Actual,
equals
because
2
you need the
pi
b
over
value though, right?
Well, but like in the case where it's 5.4,
Oh, you're saying you didn't have to do all the math?
yeah, you just skip to the step where you just plug it in at the
Because
bottom.
b equals 2 pi or
Or just swap, you mean? Is that what you're saying? Just swap those two? Yeah, because you multiply by b and then you divide by that value.
It's like
Multiply
when you're
b
solving for the
by-
denominator of like a tangent, like when you solve for the adjacent angle, you just flat out swap it instead of
Oh, okay. Totally want to see if I can do this here, guys. Real quick here. Zoom. How coolio. Zoom. Not front facing. I don't want my face. Zoom. What do you guys say? Pretty cool? Solve the calculus issue. We actually just figured out some star values. Isn't that awesome? I think that's awesome.
Where does C come in? Oh wait, that's R. That's 5. That's no. T is X. No, alternate variables always.
T is for time, right? That's the only thing. So instead of X, there's a T
yeah.
value in there. Otherwise than that, guys, you guys just figured out there's certain star values and got an equation for it. That is so cool. Yeah, we're done with 4.5. All right, see you guys on, I'll pick it up just a second here.
Can I give you 4.3 on Friday? Is that okay?
Yes,